The next thing we want to talk about are parallel and perpendicular lines. So what you can see here are graphs of both parallel and perpendicular lines. So what's important about parallel lines is we're used to saying, okay, well, they have the same slope. They have the same rate of change, okay? The same rate of change, the same slope. But what's different about them? Yes, they have the same slope, but there's something that has to be different about them. They have to have different y-intercepts, okay? And the reason for that is if they had the same slope and the same y-intercept, well, they'd be the same line, and then they wouldn't be parallel because they would intersect at every point. Okay, so if you're going to say that two lines are parallel, you've got to prove to me that they have the same slope, but that they have different y-intercepts. You've got to prove both conditions to say that two things are parallel, okay? Perpendicular lines happen when the product of the slopes is -1. Okay, but we don't want to do all this multiplication. The easier way to say that is to identify that they have negative reciprocal slopes. Okay, so what that means is, say, for example, if one had a slope of 1/2, the other one has a slope of -2/1. Okay, so reciprocal means flip the fraction upside down, but negative reciprocal means one's positive, one's negative. That way, when you multiply them, you get a negative number. Okay, so how do we use this to write equations? All right, so this is a very common type of problem that you're going to see. Write the equation of the line that passes through the point 6, -2 and is ... parallel to this equation and perpendicular to this equation. Well, if I want to do parallel perpendicular, I need to know slopes. So let's start with the parallel problem. I need to know the slope of this equation. The only way to get the slope is to get the y by itself. So I'm going to subtract over the 3x to get -5y equals -3x plus 20. Then I'm going to divide out the -5 everywhere. And that's going to give me y equals +3/5 x minus 4, okay? And these two problems are using the same equation, so I'm just going to copy this over here real fast so we have it for future reference. Okay, so the slope of this line is 3/5. So the parallel slope is also this, because the slopes have to be the same. So the parallel slope is 3/5. Okay. Now the easiest way to do this is to just write a point slope equation. Let's do y minus, we're going up here to look at what's the provided y value. Y minus -2 is y plus 2 equals our slope, our parallel slope, times x minus the x value in the coordinate point. And if the problem doesn't specify a format, this is a valid answer. Look at how quick that was, okay? I didn't have to do any work with the fraction. I could just write it down, okay? So I highly, highly, highly encourage you to work on point slope form. It can make the work a lot faster, especially when you aren't told to write it in a specific format. All right, for part B, we've got to do perpendicular, all right? So we need to identify what the perpendicular slope is, okay? So an upside down capital T, that's a symbol for perpendicular because it's creating a right angle. So the perpendicular slope, I need to do the reciprocal of 3/5 is 5/3, but I need the negative reciprocal, so I'm going to turn it negative. Okay, so the perpendicular slope is -5/3. Remember, the coordinate point is 6, -2. So now when I write my equation, I do y minus the y value, minus -2 is plus 2, equals the new perpendicular slope, -5/3, times x minus the x value, okay? So there's my perpendicular, okay? And the beautiful thing about point slope is once I write one, it's very easy to write the other. It looks exactly the same, just the slope is different, right? That's parallel and perpendicular lines.